Let us continue our discussion on designing context-free grammars. Having seen WWR, let's look at the language which is close to that, the language of palindromes. So set of all palindromes over say 0, 1 star. So if you look at WWR, epsilon is part of this. If W is 0, then WR is 0. Then if W is 1, then WR is 1, and the rest of them. And this is a palindrome, this is a palindrome, and if this is W, then this is WR. If this is W, then this is WR. So you can see that they're all palindromes. So then what is the difference between this and this? The only difference is this can have 0 as well as 1. Everything else remains the same. So which means S implies on one side you say 0 is 0, or S implies 1 is 1. Correct? That's how we relate. Or we say S imply epsilon. So which means this generates strings of length either 0 or at least 2. Exactly 1 is missing. So that you explicitly write 0 or S implies 1. Now if you bring these two productions, it precisely captures the language of palindromes. Because WWR, yes, it captures everything except these two. So you just add these two, we are done with it. Okay. Now when you look at a context-free grammar, one can talk about something called derivation. We have seen before, and derivation of a string, say W, belonging to the language accepted by the grammar, which we say L of G. This derivation has got two types. One is leftmost derivation. The other one is rightmost derivation. Meaning a string belonging to L of G, one can derive following a leftmost derivation scheme or a rightmost derivation scheme. We shall take a string and see following leftmost, how do we derive? Following rightmost, how do we derive that? Okay. So let's look at a string, say 0, 0, 1, 0, 0, and see how it is derived using this as well as using this. Leftmost derivation says at each iteration, so at each iteration what we do is we choose the leftmost non-terminal for expansion or as part of parsing. So when you want to choose a non-terminal, suppose there are multiple non-terminals in the given expansion, we choose the leftmost one. At each iteration we choose the leftmost one, then what you get is the leftmost derivation. And at each time you choose the rightmost non-terminal, then you get rightmost. Or you kind of mix, that's called mixed derivation. Sometime you choose the leftmost non-terminal, sometime you choose the rightmost non-terminal, you end up getting mixed derivation. Let's look at this. So let me start from S imply this. Now we have this is our alpha 1, and in this we choose the leftmost one. Of course you find exactly 1, so therefore we choose this and go for expansion. So again I choose this. Then I choose this production to replace this, so I get this. So as far as this one is concerned, the left, right are one and the same, because you have exactly one non-terminal. Supposing you have something like this, say S imply AB, and A says 0A and B says 1B, and we also have A imply 0 or epsilon, and we also have B imply 1 or epsilon. Supposing we have a grammar like this. Now S implies AB. Now you have two non-terminals. Supposing we go for leftmost derivation, I need to choose this. Then this becomes say 0A. Now if I follow leftmost derivation, I should choose this and then complete. Let's assume we choose epsilon for this, so we get this. Now next we go here and then choose this. For B, let me choose 1B, and in this is our leftmost non-terminal, so let me choose this, and finally I replace this with this. Okay, now this is leftmost in the sense that S implies AB and leftmost non-terminal is this, so we replace this by 0A B, and leftmost this one is this, so this is replaced by epsilon followed by this. Now in this string leftmost one is B, so this becomes 0 epsilon 1 B, and leftmost is this, so this becomes 0 epsilon 1 1 B. Again leftmost is this, so this becomes 0 epsilon 1 1, so we get 0 triple 1. Fine. So at this point in time, between these two non-terminal we choose this. Again between these two non-terminals we choose this, because we follow leftmost derivation scheme. So the same string one can also generate following rightmost scheme, which we shall see next. So for the same string, let's attempt a rightmost derivation. So we need 0 triple 1. What we do, we start from S and then we choose this. Now between these two we should expand this, and I go for 1B, and then again I go for 1B, because the rightmost is this. Then it becomes this. After that we replace this with 0. Okay. So which means S implies AB, then rightmost is this. This we replace with A 1 B. Again rightmost is this, so we get A 1 1 B. Rightmost is this, then we get A 1 1 1. Then the rightmost is this, we get 0 this. Either we can do this, or we can replace this with 0 A again, and then A becomes epsilon. So this last two steps, one can also do this, and you can expand A as 0 A 1 1 1, then replace this 0, finally you get this. Okay, both are correct. But this itself tells you something, that here is a string for which you can have more than one derivation. That shows that this grammar is ambiguous grammar. Okay. And in case you go for a mixed one, for example, you say S implies AB. Now what I do, I say it becomes A implies 1B. I choose this for expansion. And then this becomes A1 1B. Again I choose this for expansion. Now what I do, I choose this and then replace this with 0, then 1 1B. Now you see that at couple of places it is right, at couple of places it is left, so it becomes a mixed derivation. Fine. So for a string that is accepted by the grammar or generated by the grammar, one can come up with a leftmost derivation or the rightmost derivation or the mixed derivation. Okay, so when we define ambiguity, one has to be careful. So when we say a grammar is ambiguous, which means there exists a string W belonging to L of G such that W has at least two leftmost derivations. Okay, so one should not say W has one leftmost and one rightmost, therefore the grammar is ambiguous. No. To say that it is ambiguous, it should have at least two leftmost derivations or at least two rightmost derivations. Okay. So it should not be like one leftmost and one rightmost. With that, one should not conclude that it is ambiguous. No. So look at this. We follow rightmost derivation. The string 0 111 you can get via this, or at this point in time you can replace A by 0A this. Subsequently this A you replace by epsilon, you get this. Now you find two rightmost derivations for the string 0 111. Therefore this grammar is ambiguous grammar. Okay, so the notion ambiguity, when we look at compiler design parsing, it will have some issue. So it is better to design unambiguous grammars.